Yes, back to this syllabus document, electrical system. Now, MOE actually wants, or shall I say the science branch, right? They did talk about what is expected. What is expected of students in lower secondary level. Okay, so this is not exactly a national exam yet. So at lower secondary, before you move up to Sec 3 and 4, for electrical system, core ideas will be what you need to know. Okay, practices, of course, is something that you have to be able to do. Okay, and then values, ethics, and attitude need to show certain awareness, like how much electricity you are using and what will that actually lead to. Okay, the bills will go up, especially these few days or maybe these few months. It's very hot in Singapore. So I know the electrical bills of many families are going up. Why? Because you need to turn on the fan more. Sometimes the fan will not even help. You need to turn on the air conditioner. So for me, most of the time I'm at home. I try not to turn on, but it's almost impossible now. Yeah, because it becomes so uncomfortable, I can't even do my work. Okay, so this is what is this about. So how are you going to, think of ways to reduce the consumption of electricity in the household? So we have covered current. Look at the core ideas again. We have covered current, potential difference, resistance. Okay, so we talk about what is the definition of them. We stated their SI unit. We even look at a certain formula. Okay, so we have to go on today to talk about chemical heating and magnetic effects of electric current. Okay, and then the power part, we are going to leave it to the next lesson. So practices, right? We have learned how to draw circuit diagram. So we did explore. I mentioned to you, you have to use ruler to draw your circuit diagram. It's crucial that you use ruler. Make sure there are no holes at all because that will indicate certain gaps in your circuit. You will be penalized. Okay. Today, we are going to go into the variable resistors as well. You must know how to connect the ammeter and voltmeter. This V equals to IR, even though it says it's not required, still I see many schools testing for this. So we are just going ahead. Even if you don't learn it now, you're going to learn it in Sec 3. Okay, it's a very simple formula to work with. You don't have to worry that much. Okay, then investigate how series and parallel arrangement of the resistor is going to affect the current. So all these we are going to cover, some only covered next lesson, like even the cost of using electrical appliances, we are learning only the next lesson. So let's move on. This is what we have covered. Current, we talk about current being defined as the rate of flow of charged particles. Mainly, we are talking about the electrons. Okay, long ago, we didn't really understand. I mean, the scientists didn't really understand that, the electric circuit, right? Current exists because of the electrons moving. So long time ago, they didn't know. Okay, it's only after some time they realized that it's actually the electrons that caused all this. So SI unit of current is ampere. You represent it with a capital letter A. Need to be this, okay? And current we represent with capital I. Yep, don't confuse this symbol here with the SI unit. Next one. Okay, so this just shows how electrons actually flow in a circuit. It comes out from the negative terminal of the dry cell. Okay, so this dry cell, electrons flow in this direction. Okay, and then this electrical energy is then converted into this light. And then, of course, it will become heat energy as well. So after that, electrons will then move back into the dry cell, okay, by entering the terminal. So it is flowing in this direction. Okay, you will see inside your MCQ, okay, the worksheet questions, right? One of the MCQ asks you about conventional current. It's the opposite direction. So long ago, they actually talked about, conventional current flowing this way, from the positive to the negative. Okay, so yes, maybe you won't be asked in lower secondary because it's not even mentioned, right, inside the syllabus document. But because we have one question there, I'll just expose you to it. Okay, even in the upper secondary, you will not be required to explain. You just need to know. Okay, conventional current is actually the other direction. Electric circuit, we need to know the circuit symbols. Primary school, you already learned some. Okay, but of course, you need to learn additional ones. I mentioned last week as well, every one of this now, right? Okay, in general, you call it a battery. In primary school, you call it as one battery, two batteries, three batteries. But in secondary school now, you cannot call them that way. No matter how many of those cells that you are connecting, right, it forms one battery. Okay, only one battery to power the entire circuit. Your battery can consist of one dry cell, two dry cells, three, four, or whatever is needed. Okay, so one cell is actually represented by these lines, positive terminal, negative terminal. So maybe my circuit in this case has a battery made up of one dry cell. Okay, it can be more. If it's two dry cell, I will draw it this way. Okay, then connect the wires, then positive and negative. Okay, so this is how you represent it. So you don't say that there are two batteries here. You will be marked down. It is one battery consisting of two dry cells. Switch. Okay, switch. You have to be careful. Remember the two dots here. Okay, I have too many students drawing this way. Okay, if it's an open circuit, it's not too bad. But when it's a closed circuit, it seems like it's just a wire because you can't really see the two connecting points here. Okay, so this is where you have your the switch being open or closed. So with these 2 points, it's easier to see open circuit. It's easier for me to see as well that is a closed circuit. Of course, you don't draw for me to see, okay? Because the system don't allow you to draw. But in school, if the marker doesn't see that you have put in effort to show that a switch exists, you might be even marked down. Okay, don't lose marks that way. Fixed resistor, just a rectangular box like this will do. If it's a variable resistor, let's stick to this one. Okay, I would like you to stick to this one when you are drawing. Okay, with an arrow pointing in a diagonal direction. Fuse, rectangular shape, then you have a wire connecting right through. Voltmeter, you have a circle and a capital V representing voltmeter. So you have to make sure it's a cap, not a small v. Ammeter, you have a circle and inside have a capital A. Light bulb, okay. In the past, light bulb, they accept this as well. Nowadays, they don't seem to want you to draw this as the light bulb. You have to indicate, a cross inside. Okay, so this is the light bulb. Joint wires, they are not that particular with whether you put in the dots or not. Okay, so far that is what I have been noticing. When you draw circuit diagram, okay, this is the actual setup, actual connection. You have to draw out circuit diagram based on how many dry cells there are, based on, how many maybe resistor, light bulbs, etc. And you have to draw it in a rectangular manner. Make sure it is always in this manner. Okay, and then follow accordingly how the dry cells are being arranged. Where is the positive terminal? Where is the negative? When you are asked to draw a circuit diagram and then you draw let's say the dry cells having the positive and negative terminal in the wrong direction, you are marked down again. Okay, then yes, that's the light bulb. So you just have to make sure whatever you are putting in follows the positioning as stated in the actual connection. Tips for drawing good circuit diagram: must be using ruler to draw it, and it has got to be very sharp, and make sure there are no gaps. In this case, there are some gaps here, so let me fill up, the gap. It's not too good to have the gaps because that means it's an open circuit. Open circuit, that means electric current cannot flow. Okay, so there's a gap here, there's a gap here, not so good. Okay, gap over here as well, then it's not drawn using ruler. All right, you're supposed to use ruler. Now, types of circuit, we can have open circuit, closed circuit, short circuit, series circuit, parallel circuit. So these are the few that you are supposed to be very familiar with, not just now, but throughout your secondary school years. Okay? If you are going to continue in JC, of course, if you are taking physics again, you must know this also. All circuits will require basic components like this. Power source, either it's from the battery or it's from, the socket outlet, the AC or the DC connection. Okay, all this will matter in future. Conductors, we have wires to connect the electrical components so that there's a path current to flow. You must have some, working device like the electrical components like lamp, etc. Okay, then control device, switches, then protection device, the fuse. Of course, at home, we have our circuit control board, right? So that one is also another safety function, protection function. Now, series circuit, simpler circuit here, only one path for current to flow. Now, take note, in the series circuit, current is the same throughout. Okay, and then if let's say any part of the path is broken, no current can flow in the entire circuit. Parallel circuit, there will be more than one path for the current to flow through. Okay, same voltage is applied for each branch. So let's say there are lamps connected in the branches, and if the resistance for the various lamps are different, the current that flows through each of the branches will then be different. So take note, for parallel circuit, benefit is if one branch is broken, current still flows through the other branches. Very good representation will be this. Okay, two bridges here. Then this is like the parallel circuit. When one of the bridge actually collapse, they can still continue to run through, or run over to the other side via the existing one, the one that is unbroken. Okay, so that's the meaning. Potential difference, we also can call it the voltage. Now, potential difference is defined as the amount of energy needed to move an electron from one point to another point inside the entire circuit. So it's like a push. Without these potential difference, current can't flow. Okay, current cannot flow. So it serves like a push, pushing the electron to move through the circuit. Otherwise, on its own, the current will not be flowing in that particular direction. Later, I'll show you how a conductor looks like when we talk about the atomic level. A voltmeter here. Take note, if you want to measure potential difference, right, you need to connect the voltmeter across that particular component you are measuring. Okay, so SI unit for potential difference is the volt. It's a capital V. Now, it has to be connected in parallel and make sure positive terminal, right? Because if you look at the voltmeter, there's a negative terminal and positive terminal here. The positive end, must connect to the positive terminal of the dry cell. Okay, so you must make sure the wire is connected this way. If you actually accidentally connect it the other way around, okay, instead of giving you a positive reading, this needle will be pointing in the negative direction. Clear? It will be below zero. That is when you know you have connected wrongly. All right. Next, those are the things we have gone through last week. I'm just doing a quick recap. Resistance. The word resistance comes from the word resist. So when you are resisting something, you don't want something to like disturb you or push you or, to go forward towards that thing. So when there's a form of resistance, there's opposition. You are preventing something. In this case, we are talking about preventing the current from flowing through. Okay, so the higher the resistance, the lesser current can flow through. Quite easy to understand this part. SI unit for resistance here is the ohm. Okay, we use this symbol, omega. Now, it affects the amount of current flow. So great resistance, you are going to have lesser current. Okay, so I'm not going to explain this diagram again. It's just an illustration. So when the resistance is very low, a lot of current can then flow through. How many of you at